This video is on finding the area of an equilateral triangle. So we'll go over 4 cases, but in order to do this, we need to remember the 30, 60, 90 triangle. So the side across from the 30-degree angle is half the length of the hypotenuse. And the side across from the 60-degree angle has a ratio of √3/2 with the hypotenuse. And so those ratios are things that we're going to have to remember when we do these problems. Find the area of an equilateral triangle with height 9. So if the height is 9, I draw the height. And if I see this problem, this is actually not really very much different than any old area problem that we've had. I just need to make sure that I understand what I actually need to find in order to find the area of this triangle. Now, this is a triangle, so I am allowed to use 1/2 base times height, and I already know the height. So 1/2 times base, which I don't know, times height is 9, will end up getting me this area. Now, you may also see the area formula for a triangle is base times height divided by 2. That's the exact same thing as 1/2 base times height. Those two are equivalent. So my job is to find the base. So that's B for base. So that's my job. I have to find that. So if I make this X, and I realize that if I have an altitude in an equilateral triangle where all the sides are the same, the altitude is going to end up cutting this bottom part in half. So notice that all the angles in an equilateral triangle are 60. That's something that we already know. And then this gets cut in half because in an equilateral triangle, the altitude is also an angle bisector, and it's also a median and so on. So this would also be X. Now, what I can do is, since this is a 30, 60, 90 triangle, I can set this up where I see that this 30, the side across from the 30 is X, the side across from the 60 is a 9, and the side across from the 90 is the length of the side, which is B for base. Now, I could find X or I could find B. Either one is okay. I need to eventually get B, so I might as well just get B now, and I don't even need to worry about X. So if I set up a proportion, 9/√3 equals B/2. So I find B by multiplying 2 to both sides. I get 18/√3. Just a reminder, this would probably be acceptable as an answer, but I can multiply the top and bottom by the square root of 3, and I can simplify what the base is. So that's 18/√3 divided by 3, because √3 times √3 is 3, and 18 divided by 3 is 6. So B is equal to 6/√3. So the area of this is 1/2 times the base, which is 6/√3, times the height, which is 9. And if I simplify that, I get 27 times the square root of 3 units squared. Now, what if they give me something different, like the apothem or apothem? So that goes from the center down, and I'm told that that is 6. So the first thing that I want to do in any sort of problem, I'm going to actually have to use the process for finding the area. So I want to find the central angle. So the central angle is formed, this would be the central angle. So, sorry, that is the central angle. So the central angle is 360 divided by the number of sides, which in a triangle is 3. So the central angle in a regular or equilateral triangle is going to be 120 degrees. And then I split it. So I do the apothem split, and that splits my angle. So that's a 60-degree angle. Remember that all the angles in an equilateral triangle are 60 anyway. So this is going to cut that in half, and I end up with a 30. So now what I have is I have another 30, 60, 90 triangle. So now we're on step 3, use special right triangles or trig. In this case, we'll use special right triangles to find the missing necessary side lengths. So I'm going to draw this. This is a 6 across from the 30. And then what do I need to find? Well, this is the radius. But in order to find the area, let's say I want to find the area of this triangle. Well, in order to find the area, I don't need to find R. I need to find B, right? I need to find the base, basically, of this triangle. So I'll call this X, and that's what I want to find. So I want to find this X. And then once I find X, twice as big will be B. Now notice that R and B are not the same. So I can't just say that R is equal to B in this case. So 6 over 1 equals X over square root of 3 means that X equals 6 times the square root of 3. And then that means the whole base is 12 times the square root of 3 because this part is cut in half. So both of these are X. So that's 12 times the square root of 3. So now I'm on step 4, finding the area of this triangle. Now, once I find the area of this triangle, that will make my problem much easier because once I find the area of that triangle, then I can just multiply it by 3 because there are 3 triangles that are exactly the same in this picture. So I'm going to find the area of that triangle, 1/2 times base, which is 12 root 3. 12, that's not how you write a 12. I don't know what just happened. Sorry about that. 1/2 times 12 root 3 times the height, which is 6. So 12 times 6 is 72, and then divide it by 2, you get 36 square root of 3. That's the area of this triangle. Now, the area of this triangle would also be 36 root 3 because it's the same thing. And the area of this triangle is also 36 root 3. So what I have to do is I have to take this 36 root 3 and multiply it by 3 because that's the number of triangles that this shape would have. So 36 root 3 times 3 is 108 square root of 3. And that's the area of this equilateral triangle with apothem length 6. Area of an equilateral triangle with side length 14. So it's equilateral, so all the sides are 14. Well, I can do this in a variety of different ways. Since I already know that this side is 14, and all I have to do is 1/2 base times height, basically all I have to do is figure this one out. So if this is 7, I need to find the height, and this is a 30, 60, 90 triangle. So since this, if I draw this picture, the side across from the 30 is a 7, and I need to find the height, h is going to be 7 square root of 3, because 7 over 1 equals h over root 3, and you multiply the root 3 over. So h is 7 root 3. So the area of the entire triangle, because this height represents the height of the entire triangle, is 1/2 times base, which is 14, times height, which is 7 root 3. So the area of this is going to be 49 square root of 3 units squared. And by the way, on the last problem, I should have put units squared with my answer. Area of an equilateral triangle with radius length 10. So this one's the hardest one. Notice that when we weren't given a radius, I never actually had to find the radius. But in this problem, since I'm given the radius, I now have to find 2 things. So I have to end up finding this length, the base, and this length, the apothem, in order to be able to figure anything out. So once again, find the central angle. 360 divided by the number of sides is 120. And then I do the apothem split. So then this 120 becomes a 60. That's a 30 since this is a right angle, and now I have a 30, 60, 90 triangle. I have to find the apothem length and half of the base. Okay, so if I redraw my triangle, I have an A over here, a 10 over here, and an X over here. So 10 over 2 equals A over 1. So the apothem length is 5. And then 10 over 2, which is 5, equals X over square root of 3. So X equals 5 square root of 3, which means B is twice as big as that. So that's 10 times the square root of 3. So now we're going to find the area of one of these triangles. So we're going to find the area of this triangle. That's going to be step 4. And then when we're done with that, we're going to multiply that by 3 because that's the number of triangles the shape would have. And that's going to end up getting me my final answer. So 1/2 times the apothem length, which is 5, times the base, which is 10 root 3. That gives me 10 divided by 2 is 5, times 5 is 25, square root of 3. That's one of these triangles. Then remember, we have 2 more triangles. We have one over here and one over here. So we take this answer, multiply it by 3, and the area of the big triangle is 75 square root of 3 units squared.